The U.S. Army Corps of Engineers reached out to us, and they were looking for solutions for strengthening of beams, mainly supporting the crane, 140-ton cranes, and they were thinking of using FRP. The Army Corps did a great job in coming up with analysis, determining the loads, and figure out the existing deficiency in some of these beams. And they were asking, can we make the FRP work? So it would have been a perfect solution if it's technically viable. The challenge was when we went through the numbers, the deficiency was too high. I mean, the beams were operated at almost 70% exceeding their capacity. So at the time, we made a recommendation to the Army Corps that another solution using concrete enlargement would have been a better solution.
Now, in section enlargement, to properly bond the new concrete to the old concrete, a specialty technique called form and pump is used. And that technique is used because we're pumping the concrete into the formwork, but we're also pressurizing it to make sure we bond the new concrete to the old concrete.
So we shared with them some documentations from ACI and ICRI, from the American Concrete Institute and ICRI International Concrete Repair Institute. And using all this information, I think they decided this is a proper solution. And they put together specifications and, for this project based on the form and pump technique.
So structural was brought on as the GC on the project, which really brought on structural technologies as really providing the solutions directly to the client. Beyond that, there was also my role from structural technologies to come in as operations support. So we were out there heavily involved in the planning of the project, heavily involved in original approvals, materials, formwork, things like that.
The solution proposed by the Army Corps enlargement at that time included enlargement on 3 sides of these beams to add capacity. Rather than doing a 3-side enlargement, we said we can justify, technically, we feel very comfortable in showing numerically that we can do that enlargement on 1 side. And that would help a lot because it will expedite the schedule for the client and will provide really a more efficient way to do the strengthening. And the less you have work going on each beam, the faster you can finish the work, the more safe the work is. They sent us actually initially a lot of comments about the design. They were not clear how it's going to work. How are we going to put enlargement on 1 side on a beam and that would work? And they have a lot of very technical, competent people. They ask great questions related to shear transfer, load sharing, composite action, how are we going to achieve the full capacity. Once we start dissecting them and explaining how we went through them, it was very easy for them to understand our approach and see the justification for it available technically in the codes. And at the end of that call, I think they all felt very comfortable that we know what we're doing, we fully understand how the system would work, and we design it correctly.